Hey guys, welcome back to another video, and today we'll be covering another scheduling algorithm from OS, which is known as the shortest remaining job first algorithm. So we'll be looking into the simulation. So first of all, this algorithm is a preemptive type algorithm, meaning that whenever a new process comes into the RAM, if it has a lower remaining burst time, then it would switch. So there would be a context switch, and the process with the lower remaining burst time would get the CPU. So as the name suggests, so this is where we would focus on the remaining time rather than the burst time. So let's just look into an example to see how things work here. So initially we have process P1, which comes at the 0 second. So 0 second we have process P1, which works for, let's say, 1 second. And so after 1 second, the burst time, so the remaining burst time would be 5 seconds. Then at the 1 second, we have another process called P2. Now P1 has 5 seconds remaining and P2 has 4 seconds remaining. So definitely, as the algorithm works, so we would definitely go to P2 because it has a lower remaining burst time. So we would go to P2, and P2 would work for, let's say, another second. So P2 would have a remaining of 3 seconds. So at the second we have P3. So P3 has a remaining of 9 seconds, which is much larger than both P2 and P1, right? So there wouldn't be any switches. So P2 would continue from up to, let's say, 3 seconds. So P2 would have a remaining of 2 seconds. So let's say, to make it more interesting, let's say P4 has a burst time of 1 second, right? So at the third second we have P1, P2, P3 and P4 in our RAM. However, P2 has the CPU. So P2 has a remaining of 2 seconds, P1 has a remaining of 5, P3 has a remaining of 9 seconds, and P4 has 1 second. So definitely among all of these, P4 is the smallest one, right? So P4 would get the CPU, work for one more second, so 4 seconds, and it would be done, right? It wouldn't have anything remaining. So P4 is done. Then so P4 is done, right? So among these three, which one is the smallest? P2. So P2, as there wouldn't be any processes coming into our RAM, so P2 would work for the remaining of its time. So that would be 6 seconds. So P4 wouldn't P2 wouldn't have anything remaining. So we're done with P2, right? So we have P1 and P3 left. So among these, P1 is the smallest one. So P1 works for 5 seconds. So that would make it 11 seconds, and P1 wouldn't have anything remaining. Next up, we only have P3. So P3 has 9 seconds. So P3 works. It works for 9 seconds, which makes it a grand total of 20 seconds. And P3 has nothing remaining anymore. Now let's try to find out the turnaround and the waiting time. So this would be waiting. Okay, so for P1 comes at the 0 second. P1 leaves the RAM at the 11th second. So its turnaround time is 11 seconds, and its waiting time is 11 minus 6, that's 5 seconds. P2 came into the RAM at the 1st second and left at the 6th second. So 6 minus 1, that's 5. Its turnaround time is 5 seconds. Its burst time was 4, so it had to wait for 1 second. Because here we can see that there was a switch P4 which took the CPU for 1 more second. So that's why we had to wait for 1 second, right? P3. So P3 came at the 2nd second. So P3 came here, but P3 left at the 20th second. right, at the last. So it had a turnaround time of 18 seconds, and the burst time is 9, so it had to wait for 9 seconds. And finally P4, which came at the 3rd second, and it instantly got the CPU, which we can see from here. So turnaround time is basically the burst time here, and it didn't have to wait for anything. So this is your shortest remaining job first. It's a very easy one, and you always have to remember, you have to look into the remaining time always. So hope you guys like the video. If you have any comments or suggestions, feel free to comment down below, and stay home, stay safe. Thank you.